A random sample of 75 students at a large college was selected for survey. The sample size is 75. We have n equals 75. 15 of these students say that they owned a car. So X is 15 here. From this result, an approximate alpha percent confidence interval for the population proportion was calculated. So we have alpha percent confidence interval for the population proportion. Then the sample proportion is 15 over 75, which is 0.2. The width of this interval was found to be 0.162, and we are to calculate the value of alpha correct to two significant figures. We have an alpha percent confidence interval for the population proportion. The alpha percent confidence interval for the population proportion is given by sample proportion plus minus the critical value times the square root of p hat 1 minus p hat over n. The width of this confidence interval, because of the plus minus, is 2 times the critical value and the square root of p hat 1 minus p hat over n. This is the width of the confidence interval, and we are given that the width is 0.162. P hat is 0.2, so from this part here, 2 times the critical value times the square root of 0.2, 1 minus p hat is 0.8, and the sample size is 75, and that is 0.162. We need to isolate the critical value. So we divide by 2 and bring the square root over as well. So first, we divide by 2, we have 0.162, divide by 2, this 2 is gone. And when we bring this over, the square root stays, but we have to flip the fraction. So we have 75 divided by 0.2, 0.8. Or you can just calculate the value on the left, and then you divide 0.162 by the calculated value. Computing all this directly, we have Z, which is the critical value. This is 1.754. If Z equals 1.754, what we want is to find the value of alpha. So for the alpha confidence interval, since we use a Z distribution here, for the alpha confidence interval, this is 1.754, which is the critical value. We have 1.754. This is negative 1.754 to give us a confidence interval. That area is alpha. So in order to find alpha, we use the standard normal table. From the standard normal table, this is 0. This is 1.754. The standard normal table gives us the left tail area. This left tail area is 0.9603. And from this standard normal table, you have 0.9603. This part here is 1 minus 0.9603. And it is exactly the same as this area. So this area, this region has an area of 1 minus 0.9603. Sorry, this is 9603. This is 0.9603. And to find alpha, the value of alpha is 0.9603, which is the whole left tail region to the left of 1.754. And now we need to subtract this part here. We just want the central region. So we subtract 1 minus 0.9603. And this will give us 0.9206. So from here, we need to calculate alpha correct to two significant figures. We have alpha equals to 0.92 to two significant figures.